Thank you all for joining today to this live interview about change data capture with Apache Flink. I'm extremely excited about our guests today. So we have Gunnar Morling. Can you quickly wave your hand? This is Gunnar. Yeah,
hey
this is Gunnar. Yeah. He's a software engineer at Decodable. He recently joined us from Red Hat, and he's one of the co-creators of the Debezium project and was a project lead there. Then we have Leonard from Alibaba. He's a software engineer there, and he is the Flink CDC lead and a committer at the Apache Flink project. Then we have Jark. He's also a software engineer at Alibaba. He leads the Flink SQL team there, and he's a Flink committer and PMC member. And my name is Robert. I'm a software engineer at Decodable, and I'm the PMC chair at the Apache Flink project. And as I said in the beginning, this is an interview about change data capture. And my first question is very simple, and maybe this is a good question for Gunnar. What is CDC?
What is CDC? Actually, now that you ask what is CDC, I can tell you that it could stand for many things. It could be consumer-driven contracts, right? This approach of testing. It could, I mean, obviously the Centers for Disease Controls, and also my favorite, it could be the Caribbean Developers Conference. But unfortunately, that's not what it is today. No, it is change data capture. And what that means is essentially it's a process which extracts changes out of your database. So let's say you use a MySQL database or a Postgres database or Oracle, SQL Server, whatever. Now, whenever something changes there, something gets created, you insert a new customer, or something gets updated, something gets deleted. Well, you would like to react to those changes, and this is exactly what CDC lets you do. It taps into the transaction log of your database, retrieves those changes, and propagates them to any kinds of consumers, typically via Kafka, or like in our case, via Apache Flink. We can talk about the different options. And then you can use those change events and, drive all kinds of use cases, like just putting data into another database or a data warehouse, updating a search index or a cache, maybe exchanging data between microservices and all this kind of stuff. But yeah, that's CDC.
Cool. So you touched already a bit on use cases. What are the most popular use cases, or what are people mostly using it for?
So whom are you asking? Just let me know.
I think you can continue.
Okay. So yeah, I mean, the most popular one, I would say, definitely is in this category of replication right now. And this means taking your data from one data store, typically an operational database, into another system. And as I mentioned, commonly, a common use case is just data warehouses, something like a Snowflake, or maybe those streaming analytics systems or real-time analytics systems like Apache Pinot or Apache Druid, ClickHouse. And people want to do analytics in those systems. And of course, for that, they need to have up-to-date data. You don't want to do analytics on the data of yesterday. Maybe you do something like a live dashboard based on Apache Pinot, and for that, you need to have current data. So and CDC will give this to you, and people commonly use that for this replication category of use cases. Then full text search is another one. So you can do, of course, full text search in a database. Let's say Postgres has some search capabilities, but typically it's not as powerful as you would want it to be. Maybe you want to do proximity search, or like, also search matches for synonyms, all this kinds of stuff, which you would, for instance, get from your search engine like Google. And for that, you would use something like OpenSearch or Elasticsearch. And again, your data needs to travel from your operational database over into that search index, and CDC can let you do it. So that's replication. There's caching. So maybe you want to put a cache close to your users and keep that up to date. That's a common use case. And then as we talk about Flink and stream processing, then there's, of course, all this entire notion of streaming queries. So maybe you want to do something like windowed queries, and you want to know what is the revenue of my incoming e-commerce purchase orders, maybe per category, per customer type, and this kind of stuff. And you would like to incrementally update such a query. So whenever new purchase orders come in, you could then update this query and, push those results, for instance, to a dashboard. And Flink would be great for that, right? So I see those use cases a lot. Then there's microservices use cases, just exchanging data between microservices. And there you would want to use it because, well, you want to have separate databases for each microservice, right? You don't want to share databases in microservice architectures. And still, sometimes you need to share data and you need to exchange data between services. And CDC can be a tool for that. I guess that's like the most common ones.
It's quite interesting, the variety of use cases that you can cover.
And I mean, there's more. I mean, there's like audit logging. There is extracting monolith out of extracting microservices out of monolith. As we spoke about the other day, you could even use it to synchronize data between a Kubernetes control plane and a data plane, if you are building a SaaS, a software as a service. So I mean, I've been working on that for 5 years, and still I discover new use cases like all the time.
Cool. And Jark or Leonard, do you have any use cases to add or a different perspective on this?
Yeah, I think Gunnar has mentioned very many popular use cases, and I think in my perspective of view, so real-time data integration maybe is the a very common use cases. So the CDC can use it to capture change, to capture changes made in the database in real time and feed them into a data warehouses or data lake or lab system. So this can be very useful for organizations to need to perform real time analytics or on their data. Besides of that, maybe some organizations need to audit and check the data changes. For example, into maybe they want to check what changes it made in the database and who made the changes and when they were made. So it is also useful to auditing. Yeah.
Mm-hmm. Cool. So I was wondering, there is this hype cycle of technologies where in the beginning there's a lot of excitement, there's some overhype about something, and then there's a peak, and then there's some fading where people realize, oh, the technology is actually not the solution to all our problems. Where do
it doesn't solve world hunger, okay?
Yeah, sadly not. So where do you see change data capture on the hype cycle?
I mean,
Gunnar,
I can take a step at it. I would say it's definitely not at the peak yet. It's definitely going up. So as I mentioned, I've been working on CDC and this particular open source implementation Debezium for the last 5 years, and definitely the interest has grown over time. Just judging by factors like, how many questions are there on Stack Overflow, how many interactions are there on the Debezium mailing list, GitHub stars. I mean, you could say, it's like all vanity metrics and so on, but altogether, I feel it gives you kind of a reliable picture about the trend of a technology like that. And definitely I see for CDC and in particular Debezium, this is on the rise. And well, people are starting to realize, okay, there is all those use cases. And also what I sensed, once people have implemented their first CDC use case and it gives them this very low latency. So let's say I know from users in the Debezium community who take their data from their operational database, which is MySQL in that case, over to their data warehouse, BigQuery, within less than 2 seconds. So within less than 2 seconds after a transaction has been committed in the operational database, they see the data updated in the data warehouse. And once they implement their use case, their first CDC use case, and they get this sort of real-time low latency, they kind of get hooked to it and they want to build it more and more things with that. So, they don't want to go back to this batch architecture where they have maybe data from 6 hours ago or maybe from yesterday. They want to do it for all their ETL and data propagation use cases. And that's why I think it's definitely still not at the peak of the hype cycle.
And what industry trends are behind change data capture? Like, why did it appear 5 years ago? I mean, relational databases are much older than that. And like, what's the trigger for this?
Yeah, I mean, so I would say one big catalyst of that definitely is the advent of Apache Kafka and the widespread usage of Apache Kafka. And this is, well, and this is for one particular reason, I believe. So this need for this kind of data exchange, I mean, this existed before, of course. And in the past, people, let's say they were working on their Java enterprise application, let's say WebLogic, just for the, to give you some bad vibes from the past. Let's say they used WebLogic, and then they would use distributed transactions to persist something in their own database, and also then send out a message to some other systems, let's say via GMS, right? And you could do that reliably because you had XA transactions, which would span a database transaction and sending a message to via GMS to another system. And you want to have transactional guarantees there because those two things should happen atomically, right? You don't want to place a purchase order in your own database, and then for whatever failure, you cannot send out the message to the shipment or to the fulfillment system. You would end up with an inconsistent state. Now, the thing is with Kafka, you cannot do XA transactions. And also, I would just argue it's not a good idea to do this sort of distributed transaction to begin with. But the advent of Kafka, in my opinion, definitely increased the need for this kind of solution because, well, if you cannot do those two updates in your database and sending a message to a message broker, well, you always can update a single resource like your database in a reliable way. And then CDC will take messages from there and send them to Kafka, or well, to your consumers. And I think, people realize, okay, that's a powerful concept to use. Kafka made that need apparent. So I think that's one reason. And then, of course, well, yes, there were CDC solutions around before, but then really, I would say, and I would argue, of course, I'm biased, but I would argue Debezium was the one and is the one which is fully open source, which supports a range of databases, and which is really mature. And this mature open source CDC solution just didn't exist before that.
Yeah, cool. That's very interesting insights. So let's talk a little bit more about Debezium. You've mentioned this open source project a few times now. Like, what is Debezium? How does it work? Give us an introduction.
Right. So Debezium, as I mentioned, is an open source change data capture tool or platform, if you will. And it comes with support for a variety of databases. So there is also very good open source CDC tools for particular databases. Let's say there's one for MySQL, there's one for Postgres maybe. And of course, there's like commercial solutions for those different databases. But Debezium is an open source tool which gives you support for all kinds of databases. And the thing is, well, of course, in a company, you might aspire to only have a single database. Only let's have all our workloads just on Postgres because we know how to run and operate it. But reality, unfortunately, doesn't work out like that, right? There's this one team, for whatever reason, they use another database. Maybe they have just a use case which doesn't work that well on Postgres, so they want to use MySQL or they want to use whatever other database, maybe MongoDB or maybe Cassandra even. Or maybe you do an acquisition, and then all bets are off anyways, right? Because they bring their own tech stack. And now you always are confronted with the situation. I have a range of diverse database technologies, and with Debezium supporting many of them, the advantage is it gives you one unified and one common change format. So this means if you then do stream processing, let's say using Flink, or you take this data and propagate it into a data warehouse, you can implement all those parts of such data pipeline in a common generic fashion. So you don't have to think about, does this event originate from MySQL? Does it originate from Postgres? You can, do it in one uniform way. So I think that's important. And in terms of how this is built, I mean, we can dive into that, but many people use it. I would say most people use it with Apache Kafka and Kafka Connect, which is a project from the Kafka umbrella, which allows you to implement and operate such connectors, which either take data into Kafka or which take data out of Kafka. So I would say most of the Debezium users, maybe 90%, they use Debezium with Kafka Connect. But then there's also a rising share of users who use what we call the embedded engine. And for instance, that's also what's used in Apache Flink. So in the case of the embedded engine, Debezium will just run as a library within your JVM-based application. which means then a tool like Flink can take those connectors and embed them as a source, as an event source, for their own purposes without having to send data through Kafka at first, which comes with many interesting operational advantages, I would say.
So in the Kafka Connect case, is Debezium then like any other connector in Kafka Connect?
Yeah,
Or-
I mean, yeah. But from a high-level perspective, yes, it is essentially a set of Kafka Connect source connectors, which take data from an external system into Kafka. But then there's, part of Debezium is quite a few things more. So there's like built-in message transformations for different purposes. There is Debezium server, which takes Debezium and connects it to things like Kinesis, Google Cloud PubSub, Apache Pulsar, and so on. But yes, if you do use Debezium within Kafka Connect, it is, in terms of operating it, in terms of deploying it and restarting it, all this kind of stuff, it is like any other Kafka Connect connector.
And how does Debezium get these changes from a relational database?
Yeah, that's a good question. So essentially, it does what's called log-based CDC. So it uses database-specific APIs or file formats or whatever mechanisms for retrieving changes. So let's say in case of MySQL, there is so the transaction log there is called the bin log, and there's a library which gives you access to the bin log client. So in the case of MySQL, we use that bin log client, and now this essentially will trigger us whenever there is a new change event coming from MySQL. For Postgres, we use what's called logical decoding. So this is even coming with Postgres itself. You can implement what's called a logical decoding plugin, and then you just establish a JDBC connection a JDBC connection to the database, and then it will give you this stream of changes using those logical decoding plugins. For Cassandra, to give a different example, there we actually run on the individual Cassandra hosts and we access files from the file system, the transaction logs from the file system. So that's all to say, there's those different ways for integrating or for extracting those change events. There's definitely different file formats. And the good thing is, as a user, you don't have to care about that. Again, you just get those uniform change events via Kafka, via Flink, or whatever. So all those nested details, we in the Debezium community solve them hopefully once for you, and then you just can reuse those generic change events.
Cool. And do you have to have different implementations for different versions of these databases, or like how complicated is this in practice?
Yeah. Yes, it depends. So mostly those contracts tend to be rather stable, and then there's new features. So let's say Postgres, it's a very good example. They add new capabilities to this logical decoding mechanism in newer versions. So let's say in version 15, which is the current Postgres version, they added the capability to filter the change event feed, which you get straight within the database. So, that's a very common requirement. You don't want to get all the changes for all your tables. You don't want to send them out all to Kafka. Maybe there's just a subset of tables you're interested in. And now, before Postgres 15, this kind of filtering would happen in Debezium itself. So it means we would get all the table changes from Postgres, and then we would discard maybe 90%, which obviously isn't very efficient. So whereas now with Postgres 15, there's an ability to filter this straight in the database. So that's like an incremental improvement, and it's not that much work to take advantage of those new capabilities. It's just a matter of doing it. But then there's other examples, like in MongoDB, for instance, where we initially hooked up with the op log. So that's how the transaction log is called in MongoDB. So we went straight to the op log and used a mechanism for getting changes from there. And then, I don't know, in MongoDB 4, I forgot the exact version, they added an official CDC API change streams, which really gives us all those capabilities we are looking for. So now we implement CDC for MongoDB using those change streams, and that's kind of a new implementation, or a larger set of changes. So yes, it depends. That's my long-winded way of saying that.
Yeah. And for the Cassandra case, you said that you're running on each host and you're accessing the transaction log locally. So does this mean that you really have to manually deploy something on each machine, like
Yes.
some binary from Debezium or something?
Exactly right. So Cassandra is actually the one that's the odd child of the Debezium family, the Cassandra connector. I mean, everybody loves it. Okay, it's not, we don't like it, but it's a special child. So because it actually is not based on Kafka Connect right now, it is really its own process, its own runtime, its own binary, which you then have to ship, exactly as you say, to the Cassandra nodes in your cluster, and then run them there, and they will, access those files straight from the file system locally.
And then you also need to have a network connection to each of these local agents.
Yes, exactly.
Yeah.
Right. We hope to move this over also to Kafka Connect, because it's, it just means it's operational friction if people use the Cassandra connector and any of the others, because it's just different ways for going about it. Maybe what we could do as a first step is to actually move this Cassandra connector over to Debezium server. So as I mentioned, Debezium server it's another runtime which you can use to connect Debezium to all kinds of messaging infrastructure. And we could at least use the same way of running Debezium also for Cassandra, to get changes from Cassandra. So then we would, it would be a bit odd internally, because Cassandra would be its own kind of connector, and then there would be all the Kafka Connect based connectors, and Debezium server would abstract it from you, but it would make things a bit easier for you as a user.
So I forgot to mention in the beginning that the audience, the live audience of this interview, can ask questions via Zoom. So there is a Q&A button, and I think also chat functionality. If you want to extend or dive deeper on a topic or something, then use this feature, and I will use this for my questions as well during the interview. So another thing I wanted to discuss is how to like whether it's possible to read data in parallel, or whether it's only like from a single node. So I guess from Cassandra you can of course read it in parallel from each node, but
right.
For example, if you have a Postgres cluster or so, can you read data concurrently or only with a single thread, basically?
So again, that depends a little bit on the life cycle phase this connector is in, because essentially, if you look at such a Debezium connector, there's two life cycle phases which there are. So there's the regular streaming mode, where we do what I've been talking about so far. We extract changes from the transaction log and send them out as they happen in real time. The thing is, when you set up a new connector, very often you would like to start with a complete initial snapshot of your data. And now you won't have the transaction logs from, I don't know, weeks or months or years ago, because, well, it would just take up too much space on your hard disk of your database, which means for taking this initial snapshot, we actually go to the database and scan its existing tables. And then we start to stream changes from the transaction log at that particular point in time, let's say, right? I mean, in terms of transaction time or offset in the transaction log. And now, if we are in this streaming phase, well, we cannot really parallelize that part, because, well, that transaction log, that's just a sequential thing, right? It's an append-only, globally ordered log of events. So you read that just sequentially. And also, there's no need really for parallelizing that, because, I mean, a database itself uses that to keep replicas up to date, right? So it just needs to be able to keep up with whatever write load you put onto it. And that's just fine. But what we can parallelize is this snapshotting phase. And actually, Jark and Leonard can talk more about that if they want to, because there is a newer notion which exists in Apache Flink CDC, and which also exists in Debezium, which we call incremental snapshotting. And this actually means now this snapshotting process, it actually can be parallelized. It could, for instance, happen for multiple tables concurrently. And in theory, even for within the table, I guess, but we don't do that in Debezium, but maybe that's done in Flink CDC. But so again, to wrap it up, so yes, this snapshotting, this incremental snapshotting, this is something which could be parallelized. and stream reading, that's a sequential thing.
And how do you do this initial scan of existing tables? So you just do like a select star via JDBC, or is there something more sophisticated?
Yeah, so that's what we did in Debezium initially. We literally would issue a select star. I mean, you could customize it, like what columns you would want to select, or should it be ordered, or should you exclude, like logically deleted rows, this kind of stuff. But yes, it would essentially just select all the tables, all the rows in a table, and give them as events to you. Now with this incremental snapshotting, that's a bit more sophisticated because there's a few shortcomings with this very basic approach. For instance, it's not interruptible, it's not resumable. So now let's say you have a table with 1 billion rows. Scanning that and retrieving all 1 billion rows from the table, this can take many hours. And maybe, I don't know, your VM crashes and you just are in the middle of this process and you need to restart. Now with those initial, with those basic snapshots, you couldn't resume. It wasn't resumable. So this meant you had to restart this entire multi-hour process again, which obviously is not great. Now with the incremental snapshots, it's actually a bit smarter. And I mean, we can dive into it, but it's a little bit involved. But essentially, we run multiple chunk transactions, which, let's say, give you 1K or 10K records each time. And they are sent out to Kafka. So that's like individual small transactions. And we also memorize, essentially, because it's ordered. So we order those records by ID, essentially. And we memorize how far we got. And this means, for instance, we can resume, let's say we read up to primary K 50,000. Then we know, okay, we need to resume the snapshot at the next ID coming after that. So that's resumable and not as basic as the other implementation.
And I guess you can read multiple of these blocks concurrently, right? Like you can start at different offsets at the same time.
Yeah, so you could in theory. We don't do that in Debezium right now.
Okay, I see. And this is supported by all databases?
And no, it's not supported for all databases, or maybe it is. I'm not sure. It's what we kind of made that also incrementally. So we brought it first for, I believe, MySQL and Postgres. Now it's there for Oracle. But maybe by now, actually, all the connectors do support it. I do know MongoDB does it. I'm not sure about Cassandra, for instance.
And how do you connect to the database for such an incremental snapshot? Is it also just via regular TCP connection?
Yes, that's just plain. That's a plain JDBC connection, really.
Okay, so there's like a special instruction or something that you send via the JDBC connection.
Oh, you mean to kick this off?
Yeah.
Yeah. No, that's that's actually, so there again. And I'm curious how it is in Flink CDC, by the way. But from a Debezium perspective, there's different ways for doing it. So there's what we call the signaling table. So the signaling table essentially is one way of interacting, of communicating with the connector, because there you would insert into this table, you would insert a command like, hey, start this incremental snapshot for my customers table. And then as we retrieve this insert from the transaction log, we will realize, okay, actually that's this command which tells us, okay, we should do this snapshot. Now, the problem is this requires you to write into this operational database. And sometimes I know CDC users, they only would like to have read access from their CDC process to their database. They don't want to have write access for CDC purposes. And this is why, for instance, there's also another way, at least for the MySQL connector in Debezium, to send a Kafka message as the command to, trigger a snapshot. And of course, well, I mean, in the end of the day, there should be an HTTP API, a REST API, which allows you to interact with Debezium that way. It's just a rather uncommon thing in Kafka Connect, but we totally could do it for a Debezium server, for instance, to have such an API, which we then could use to trigger snapshots.
And how does the handover work from, let's say, the snapshot phase to the incremental log reading? Because you somehow need to make sure that you're stopping at the right point in time with the snapshot, or that you know where to start reading the transaction log, right?
Right. And this one is very different between those, let's say, classic initial snapshots and those new incremental snapshots. So for the classic snapshots, the initial ones, essentially the way it works is you would start a transaction for doing your snapshot, and there you would select the current offset position, like the current block sequence number in Postgres, for instance. Then you would do your snapshotting, and then when you are done and you do the stream reading phase, you would say, okay, I would like to start at this particular LSN, and then you would be sure it's like a seamless transition. For the incremental snapshotting, it's actually it's a bit more involved, because this incremental snapshotting happens concurrently to the stream reading. So what it means is, it's not like, okay, you first get all the snapshot events and then you get your incremental events, you get them at the same time. And this means, that there's some interesting semantical differences to this initial snapshotting approach. So for instance, it's not guaranteed that you would get a snapshot event for each and every record. If while such a snapshot chunk is running in the incremental snapshotting, and you would do an update to a record, then we actually would give you just this update, and we wouldn't give you the backfilling record from the snapshot chunk. So there's some sort of deduplication. It also could, for instance, mean you get a delete event for something, and you didn't actually get this snapshot record before, because we figure, okay, you're just about to delete this record, so we don't need to backfill it actually. And I guess it's getting a bit too much into the details, but there's some behavioral differences you need to be aware of. But it also means, for instance, you don't have to wait until this entire snapshot is completed, because, well, you already can start streaming changes. Or maybe you want to just backfill a particular table and keep the incremental log reading running in parallel, and you can all do that with the incremental snapshots.
Okay. Since when are these incremental snapshots available in Debezium?
That's a good question. 1.6, so maybe like a year, roughly. Okay. like a year. And interestingly, and I think really Jark and Leonard should talk also about it, because the credit where credit is due. This notion of incremental snapshots, this is not something which we in Debezium invented. Actually, this is coming from the Netflix team. So Netflix, they do lots of stuff, obviously, and they also built their own CDC implementation internally. And at some point, they share plans to open source it. So this was like in 2019. But then they never did it. So this Netflix CDC never saw the open source light until this day. And I'm not sure whether they would still do that. I believe probably not. But what they did do is they wrote a research paper about this notion of this watermark-based incremental snapshotting algorithm. And this is what we implemented in Debezium when I talk about incremental snapshots. And interestingly, also, I guess it was you, Jark and Leonard, right? You implemented the incremental snapshotting in Flink CDC based on that same paper from Netflix.
Okay, so let's talk quickly about Flink CDC to understand what it is, and then we can talk about the implementation of incremental snapshots in Flink CDC. But before that, there is one question from our audience, and that is about, so I'll just read the question. Many SQL DB vendors are finally recognizing the importance of push-based use cases that CDC currently serves. Do you think we will see a SQL standard encapsulating these operations, such as a subscribe command?
Right. So first of all, hi Mark. He's an ex-colleague and friend from Red Hat. Nice that you're here. So yes, I totally expect it. So it's my firm belief that, and we already see that all databases will have first-class built-in CDC capabilities going forward. And you already see it in newer, let's say, new SQL stores like CockroachDB or Yugabyte or ScyllaDB. They have CDC interfaces from the get-go. So for them, I mean, to be honest, all of what we do here, like going to the bin log and then using logical decoding, going to the log files in Cassandra, I mean, it's all like a bit like a hack, I would say, right? And it definitely, CDC is an afterthought, or has been an afterthought for those database vendors. And I think that's totally going to change. So they will have, and newer ones, as I mentioned, have it already, first-class CDC interfaces, change feeds, if you will. Will it be part of SQL? I guess. I mean, why not? But I totally would expect at some point you would look at a database which doesn't have a really good change feeds capability. You would find this one as odd as a database without, I don't know, without a select. It would just be really weird. So that's my opinion on that.
Cool, thank you. Yeah, go ahead.
I think this will be a very useful feature in the future for a database. As far as I know, KSQLDB from Confluent, they also have a similar ability called image change. So you can select stuff from a K table and image change, so you can get the changes from the table. And yeah, this will be a very useful feature for SQL users. And as far as I know, as the International Committee for Information Technical Standards group, there's a group, there's a streaming SQL expert group that they are making able to come up with a streaming SQL standard, and yes, of course, there is a similar feature in the design called subscribe, and many experts in the group, including Snowflake, Oracle, Confluent, Google. So the discussion in the group has been for years. So and many good progress has been made. So I think in the future, maybe not long future, there will be a standard SQL standard, maybe a draft. We can see such thing. Yeah.
Cool. I didn't know that the SQL standard group is discussing this already.
But I mean, that's what you say. That's even more, right? Because that's like really about streaming SQL and also incrementally giving you query results, right? Whereas here with CDC, we essentially just give you changes to the data itself. We couldn't give you like a delta to a query.
Yeah, it is a very big topic, including how the time attribute works in the streaming data, and
right.
How the window works in the streaming data, and how to issue a continuous query. Yeah, it is a bigger topic.
Yeah.
Okay, so let's talk about the Flink CDC Connectors project. And my first question is, what was the motivation to create this project?
Flink CDC project was created in 2020. The project was initially derived from a Flink improvement proposal. Timo and I designed the proposal at the beginning of 2020. So the purpose of the flip is to make Flink SQL easily to interpret and process change logs from databases. So the flip proposes a new interface of table source to emit a change stream. The change stream consists of insert, update event, and delete events, which Flink SQL can recognize and process. So the Flink SQL can process the change stream just like how the database to process them. So you can use Flink SQL to easily aggregate and join or enrichment or filter them, just like to manipulate a MySQL table. So you can just create materialized views on MySQL tables. So in addition, besides all that flip, we also have built-in support for a Debezium format, which we can integrate the Debezium records in Kafka topic and integrate the topic into a change stream. So users can use the Debezium, can deploy the Debezium and capture changes from various databases like MySQL, Postgre, and feed them into a Kafka topic. And Flink SQL can consume the Debezium records in the Kafka topic and interpret them into a changelog string. And you can use ProSQL to process the changelog string, just like you are manipulate. You are work on a database table. So when designing the flip, I look into the Debezium docs and was totally attracted by the Debezium embedded engine. Just mentioned, Gunnar has mentioned that. Yeah, the Debezium embedded engine is very awesome. So you can it allows Debezium to be a small library and embedded into other systems. So at that time, I imagined to embed the Debezium into Flink source, so that Flink can connect to databases to connect to database the transaction logs and process the logs without deploying Kafka topic and the Kafka connect. So the idea makes me very excited. So I can't wait to develop the first POC once the new version of Flink is released. So here comes the Flink CDC project, and it just taken me about 1 or 2 weeks to finish the first version, and because Debezium is very because Debezium has done almost majority works, so I just wrap the Debezium into Flink source. So in the first version, it also includes the MySQL CDC and the Postgre CDC connectors. So you can use Flink SQL, the per SQL text to directly connect to MySQL table and the Postgres tables and join them and aggregate them without deploying anything others. And so after that, I open sourced the project called the Flink CDC Connectors and shared the project, how to use it and share the project in a webinar in China. And many Chinese users love it, and soon some people will use it in the production environment and the GitHub start grows very rapidly after that. Yeah.
Cool. That's a great success story. So can you talk about any known production users of Flink CDC?
Yeah, I think maybe Leonard can share some product users.
Yeah. Perhaps the number are more impressed to everyone. The Flink CDC project is the most popular Flink ecosystem project from the GitHub. In the past 2 years since we created the project, it has 78 contributors, more than 3,000 GitHub stars, and with 1,000 forks and more than 1,000 issues. Of course, we closed 500 of them. A really rapid growth rate. We only take 2 years. And in the past Flink forward Acer, more than 10 experts from the top company from Chair shared their Flink CDC use cases in production, including Alibaba and Tencent and Xiaomi technology and Shunfeng technology. And the Alibaba Cloud, Tencent Cloud, and Cloudera all provide the CDC connectors in their streaming computing service. I created the Flink CDC community DingTalk group last year. The DingTalk is a software like Slack. Now it has grown to more than 7,000 people. It's a big number. We only take 1 year.
Cool. So let's hope that the growth rate continues like that, so that we have 14,000 next year.
Yeah.
Cool. So these are pretty impressive numbers that show the adoption of the Flink CDC project. So I have a few, let's say, technical questions about the Flink CDC project. Does it support all databases that are supported by Debezium, or is there any per database work needed in the Flink CDC project?
At the beginning, at the beginning, we use Debezium to connect databases, mostly including the MySQL CDC and Postgres CDC, and also including SQL Server, Microsoft SQL Server, and DB2. Apart from that, we also introduced the MongoDB CDC several months later, and as a contributor, use and MongoDB published a new change log stream ability in a new version. So we use the SDK provided by MongoDB and integrated it with the Flink CDC. Yeah. So some of the connectors are using Debezium, but there are also some other connectors. For example, MongoDB and TiDB and OceanBase are using other technologies. Yeah.
Other technologies meaning other libraries, or is it something that the Flink CDC project built themselves?
Yeah. For example, the OceanBase, the CDC technology, they have a log proxy client. You should you need to start the log proxy client to pull the change log from the server, and we have the TiDB offer the CDC client, a Java client, and also offer the Go client. You need to start the client and then pull the change log from the server.
Okay. There's a question from the audience. Why did Flink CDC choose to use Debezium instead of Canal, which is commonly used in Alibaba? What are the biggest differences between Canal and Debezium?
Yeah. One of the biggest reasons is that the Debezium support to read the table, both snapshot and increment. So you can Debezium provide an initial startup mode, so you can read the existing data in the database and continues to read the change logs in the change logs after the at the time in point. Yeah, but Canal just support to read the transaction log. So it doesn't support to snapshot reading, and you know the database can't store all the transaction logs forever. It consumes much hardware, so maybe you just store 1 day or 7 days, so you can't just to read the transaction log. You have to read the snapshot data. Yeah. This is one of the reasons. The second reason is that Debezium provided embedded engine and the API is super simple, so you can very easy to adapt it to a Flink framework.
Yeah.
I mean, I can maybe add one. I mean, that's cool. I did not know that that this was the reason. That's really cool. I guess another factor which could play a role for other connectors going forward is that the Debezium change event format, I mean, it's not a standard itself, but I would argue it kind of is becoming a de facto standard, because what we see is, I mean, so yes, we do have those connectors which are part of the Debezium project itself, And by the way, there we have like two kinds of connectors, some which are maintained by the Debezium core engineering team. And then there's others, what we call community-led connectors. So that's right now the case for Vitesse and for the Cassandra connectors, where it's actually, other teams, for instance, by Stripe or Instacluster, who maintain those connectors. But all those are part of the Debezium organization and the Debezium project itself. So it means if there's a new Debezium project, new Debezium release, you would get all those connectors as part of that release, and the source code is in the Debezium GitHub org. So it's part of Debezium. But then interestingly, there's also other Debezium-based connectors which are maintained elsewhere. So for instance, ScyllaDB, which is like a NoSQL database, Cassandra-like, Cassandra-compatible, but implemented in C++ by Scylla. So they realized, okay, we would like to have a CDC story. And then they said, okay, let's actually build our ScyllaDB CDC connector on using the Debezium framework, because, well, we save time. We get quite a few things for free, like the snapshotting largely is done for them. Message formatting, how you go about type conversions, all this kind of stuff, filtering, transformations. So they get this for free, and they just will need to hook it up with the database specific parts. But then also they benefit from this format aspect, which I mentioned. So now, as their connector also is a Debezium connector or a Debezium based connector, this means as a user, again, it doesn't matter, does this event come from Postgres or does it come from ScyllaDB? You can handle it uniformly. And we see that the cases where I saw that is with ScyllaDB. Then there's Yugabyte, who also do their CDC connector based on Debezium. And there's another very prominent database, which I cannot mention yet, but who are going to announce their Debezium-based connector very soon. And I think then again, it makes sense for Flink to incorporate Debezium, because it, gives all CDC events from all those databases in a uniform way into those streaming pipelines.
So in my understanding, Flink has support for the Debezium format, and you can also output Debezium events from Flink. So you can do a join between MySQL and Postgres in Flink, and the output of this join is again a chain stream in Debezium format.
It's like fake Debezium. Okay, boo. No, it's cool. I like it. It's awesome. I didn't know that.
So let's talk about the incremental snapshots in Flink CDC. And as I understand, Flink CDC is not relying on Debezium for that, but it has its own custom implementation for that. So can you share the motivation for this and what's different from Debezium?
Yeah. Okay, go ahead.
Okay. In the first version of Flink CDC, we mainly integrated with Debezium, but we found many issues. And the one is that we want to achieve the data consistency. The database needs to be locked, and the other is the snapshot rating can only be performed, cannot be performed parallelized. It can only support a single load, but Flink is a distributed system, so we want to make it parallel reading in snapshot phase. Besides, the lock is very dangerous for database. If user want to achieve the exact nuance semantics, they have to use the lock in early Debezium version, but it may make the database danger. So based on these problems, we look up many materials. The most important is the Netflix DBlock paper, but we do not directly use them because the DBlock paper is need write access. They need write the singular to a singular table in database. not all CDC users can apply the axis the right axis. Maybe they have only the right axis, so only have the read axis. So based on the Deblog paper and combined with the Flink's new source framework design, we implement a variant algorithm, which we call the incremental snapshot algorithm, which implements parallel reading in the snapshot phase. The snapshot phase will also support a checkpoint based on the incremental snapshot, and then we can smoothly switch to incremental the transaction log reading. And this is not like the other integration platform. They need a user to operate the snapshot and the transaction to make sure the exact one is semantics. But in Flink CDC, it can make sure by the framework. So the entire process guarantees the final consistency of the data.
Mm-hmm.
And we didn't have the incremental snapshotting in Debezium back then when Flink CDC implemented it.
Yeah. When we start the incremental snapshot in Flink CDC, the Debezium not offer the incremental snapshot. And in the first version, incremental snapshot of Debezium, if I remember correctly, the Debezium still need the right axis because they need to create a table in database. So at that time, we design a new incremental snapshot. And at the same time, we consider it, we want to support parallel reading in snapshot phase. So we designed a new incremental snapshot.
Right.
Yeah, I will add some information that the difference between Flink CDC incremental snapshot and the Debezium snapshot. First of them is that the Flink doesn't support the signaling table. Yeah, Debezium will use it to maybe trigger a new snapshot on a table or add a new table to read. Such something like some ad hoc snapshots, but Flink CDC doesn't support it. And the second difference is that Flink CDC, Flink CDC is mainly used in Flink SQL. In Flink SQL, so one of the requirement is that the change string have to guarantee exactly once. So you can't read a array code twice. But in the Deblog paper, the algorithm will emit the change logs, all the change logs, and after that they will emit the chunk records. So when you, for example, when you issue an update in the database during the snapshot time, you may read twice for a record as an insert record or a read record. So these two records goes into Flink SQL. For example, there's a word count aggregate, so it will be a wrong result because there are duplicate records in the source. This is a limitation for Deblog algorithm when we adapt it into Flink CDC. So we actually to modify the algorithm to emit the change log string with exactly one semantics.
And how did you do that?
Yeah, the core idea is that we will also split the table into chunks and read the chunks in concurrently. So when you read a chunk, we will firstly remember the current bin log position, and after that we will issue a query to select the chunk data and buffer it in the memory. After that, we will remember the current bin log position, the new current position, and so we have the start position and the end position. We will read out the bin log in the range and merge the bin log into the chunk data in the memory. So after that, we got exactly one consistent snapshot of the chunk. So we will emit out the chunk data. So after read out all the chunks data, we will get many bin log positions, and when we switch to the bin log position, when we switch to the bin log phase, we will read all the bin log position one by one and filter out some data not belonging to the chunks. Yeah.
But can you? I mean, you still could have duplicates across chunks, I suppose. So you do get. Let's say there's this first chunk running right now. So you do, and you get an update event for a particular record while this is running. So you would emit that update record, and then if the next chunk select is done, this might be the window where you would do the backfill for that range of records, and you would do an insert, I suppose. I mean, that's my question. Could this happen? I get an update, and then I get this backfill record in the next chunk, or do you also prevent that somehow?
When you issue an update, so during the snapshot, we will when we snapshot a chunk, all the records will be merged into will be merged. So all the data in the memory are insert events. So they will be output as insert event. And during the next chunk, during the next chunk reading, it will filter other events doesn't belong to this chunk.
Okay, but so this deduplication is called. This always only happens within a specific chunk, right? It does not happen across chunks.
Yes.
Okay.
So you got a bin log position for every chunk.
Right.
The exactly consistent bin log position for this chunk.
Yes.
For example, you have 1,000 chunks, so you have 1,000 bin log position. So when you switch to the bin log phase, we have to start from the first bin log position and go through the bin log. We will filter the bin log position which we have processed the chunk data.
Right. Okay. And so what I'm trying to say is this situation which I described. So you get an update, and then in a future chunk, you will do this insert for this record. This totally could happen, I would say.
Could you repeat that question again?
Yes. I mean, so let's say you are within one chunk and you do an update, then you would realize, okay, if I get the same record from this snapshot select I do for this chunk, then you would deduplicate it and you would just emit, I guess, this update event, right?
Yes, yes.
Right, but now if you have two chunks and you get this update in the first chunk, and then in the second chunk you would do this this insert from the snapshot select, you would still emit this this insert. So you would, in the first chunk you would emit the update, and then you would emit the backfill event, if I understand correctly.
During the second chunk, you will ignore the first update. You will ignore the update on the first chunk.
Yeah, right.
Yeah.
Which means you would then emit this insert in this second chunk. I mean, we can talk about it separately.
Exactly.
I'm curious, but we can talk about it separately. No worries. Sorry.
I think that maybe we should debug.
Maybe we can
stuff.
have some.
Just since I'm not sniped. Sorry.
Okay, so let's take this debug session offline. And
no, let's do it all together. All the people who are code. Let's go straight to the source code.
Yes, let's do screen sharing. So are there, like, what is going to happen in the future of CDC? So we've touched on this a little bit with modern databases having CDC as like a first-class feature. But what's on the roadmap for Flink CDC, and maybe also later what's on the roadmap for Debezium, and maybe the space as a whole? I don't know what makes sense, but maybe let's start with the Debezium, the Flink CDC plans first.
Yeah, so community will firstly we will plan to support more data sources and support more and migrate some and migrate more connectors to support the incremental snapshot framework. And we have extracted an incremental snapshot framework to support to make new connectors to easily support the incremental snapshot. So we will support more connectors and more connectors to support incremental snapshots. And secondly, we will provide some ability with the data pipeline, for example, how to provide reading rate limiting to reduce the query load on the databases during some snapshot phase. And we will provide more monitoring metrics to let users to have more information about this pipeline. And thirdly, we will improve the end-to-end story of the Flink CDC, because in many use cases, in some use cases, the source and the Flink SQL and the things should work together to, for example, for real-time integration. So for real-time integration, so for real-time data integration and real-time virtualized view. So we will provide some end-to-end solution or end-to-end user story for that. Yeah.
So what do you mean by real-time data integration?
Yeah. For example, many one of the useful use case of CDC is real-time data integration, where we can capture the changes in the database and feed them into some data warehouses or some, for example, Snowflake and some real-time OLAP systems like ClearHouse, Trino, Pinot, and Apache Stories, Jark, and many of the OLAP systems. So one of the requirement of the data integration is that how to synchronize the whole database into the OLAP system. So it is currently it is hard work for the Flink CDC. You have to define the schema for every table and you will have many connections to the database, and the database will be in a high will be in a high load. So we are looking for some solution for end-to-end story to reduce the data integration work.
Okay, so for synchronizing entire databases, basically, like all tables of a database and stuff. Okay, I understand. Okay, thank you. And Gunnar, very briefly about Debezium, what are the plans for the future?
I mean, yes, so there will be new connectors for sure. For instance, MariaDB that comes up all the time. There's lots of work going on in the Debezium UI. So that's a thing we didn't talk about at all, but there's also a web-based UI component for Debezium, which is expanded over time. And interesting, also there is this end-to-end story which Debezium wants to address better, because right now, if you think about such a data pipeline, I mean, there's 3 parts to it, right? There's how you get data into it, and Debezium answers that. Then there is how do you get data out of it, and Debezium doesn't answer that. And then there is how do you process your data, merging topics, filtering topics, joining topics, and so on, or data, let's say, streams. And at least for this end part, Debezium also wants to add support. So that there should, for instance, be a Debezium JDBC sync connector, which then works very well with Debezium and its change event format. And, it understands all the types, all the metadata, and so on. And then you could very easily, very smoothly set up an end-to-end data flow from Debezium, or from one relational database into another relational database using Debezium. So JDBC sync, maybe Elasticsearch sync, this would be things which could come in Debezium as well.
Cool. Interesting. So before we wrap up, are there any other questions from our live audience? If so, now's the time to put your question into the chat or the Q&A.
Depending on where they are, they're getting hungry for the lunch break, I guess.
Yeah. Yeah, we are a little bit over time. So I don't know. We never set a time beforehand intentionally. Okay,
you never can talk enough about CDC anyways.
Yeah. I have some questions left actually, but I think it's enough for now. Okay, so there seems to be no more questions from the audience. So then the only thing that remains is to really thank you for answering all my questions. I really enjoyed the time we had together, and I hope the audience learned as much as I learned in this interview. So thank you very much. It was really nice.
Thank you for having us.
Thank you.
Thank you.